this video, we are going to discuss integers. We are looking at a whole new side of the number line today, which is extremely exciting. So let's get started. All right, so integers, as you guys can see here, are the counting numbers. So 1, 2, 3, 4, 5, 6, and so on. They're opposites, which is the whole left side of the number line here. So as we can see, 6 and -6 would be opposites, 1 and -1 are opposites, and so on. Every integer has, every counting number or whole number has an opposite. Opposite of 2 is -2. They are the same distance away on the number line, just on opposite sides. This little negative symbol really can be read as opposite of. So again, we have our normal side of the number line, that are regular counting numbers, their opposites, or the negative numbers, and then 0. And as we know, 0 is not positive or negative. It is just pretty much the dividing point. So it is a neutral. It's kind of like a neutron, if you've talked about those before. All right. Integers must be whole values, so they are not decimals or fractions. So for instance, 1/2 is not an integer because it is a fraction. They must be whole values. All right, let's keep going. So we already talked about opposites and how they are the same distance away on the number line, just on opposite sides. So this, and we already talked about how the opposite of 6 would be -6 because they are on opposite sides of the number line, but they're both 6 counts away from 0. So if that policy holds true, what would the opposite of 7 be? I have 7 hops from 0 to 7, so the opposite would be -7 because I would have to make 0 hops to the left. 7 is 7 hops to the right. -7 is 7 hops to the left. So the opposite of -7 would be 7. All right, let's keep going. All right, so we just said that the opposite of -7 is something we just said. We can write that mathematically, and if we remember that that negative sign also means the opposite of, we can use that. So right here, instead of just writing, so -6 would mean the opposite of 6. If I add another negative sign, this would mean the opposite of -6, which would in fact be 6. So another example, the opposite of -8 would be 8. Basically, that double negative makes a positive. All right, let's keep going. All right, so the opposite of 4, which would be right here, just before 5, would be -4, which would be just before -5. And then 0 is right in the middle. 4 is 4 hops to the right. -4 is 4 hops to the left. So the opposite of -4, which would be written as this, would be equal to 4. Again, opposite of -4. That first negative sign means the opposite of. That second negative sign also means opposite of. So opposite of the opposite of 4, which brings you back to 4. I know that part's a little confusing. We'll talk about it more. All right, let's keep moving. All right, so now let's talk about how we would put numbers in order. So I have a list of temperatures here for a week. And these, as you can see, some of these temperatures are in the negative, so this must be somewhere where it's really cold. Maybe somewhere like in Alaska or somewhere that gets very, very cold. Even sometimes it gets this cold here in Massachusetts. First, it's asking us, what is the coldest day and what is the warmest day? So what I see here, the warmest day, so if I look at a thermometer, let's go back and look at that picture of a thermometer. The warmest day would be that +4, because positives are above 0. The coldest day, let's go back. Coldest day would actually be -5, because this is the furthest below 0. So this is the furthest below, which is the coldest. And this is the highest above, or the warmest. You guys will also notice that the coldest temperature is also furthest to the left. The further left you go, the colder or more negative or less you get. The further right you go, the more you get. I always like to remember left is less with the double L's. Left is less. And again, that's going to mean the further left you go down the number line or down the thermometer, the colder it gets, which means the less the temperatures, the less the numbers. All right. And last but not least, let's talk about how these negative integers can be used. They can be used in situations like we just talked about with temperature. Temperatures can get below 0. We can also use this to talk about elevation. Sea level is a great example of 0. Anything above sea level, or where the ocean is a positive elevation. Anything below sea level, or where the ocean hits, is negative elevation. So as we can see here, this plane is flying at positive 10,000. And then this whale is actually swimming at negative 10,000. This plane is 10,000 above, which is positive. The whale is swimming 10,000 below, which is negative. So the whale's elevation can be described as negative 10,000 because it's swimming below sea level. All right, we are going to stop right there for now, and we will keep talking about this. But for now, we will be done, and we will see each other soon. All right, bye, guys.